Okay, so hi everyone, welcome to Ask Teacher J channel. And for today's video, I will demonstrate one example problem related to property changes of mixing. So I got this example problem from the textbook Introduction to Chemical Engineering Thermodynamics 8th edition. Alright, so let me set it here. Okay, so yeah. I will demonstrate or I will answer this word problem, and I hope you will be able to follow through, especially on the mathematical relationships that are involved between property changes of mixing, excess properties, and partial molar properties, because these properties are relevant in this context, of course, in the design of mixing tanks, because at a certain composition, there might be expansions or contractions of the overall mixture volume after you mix two or more substances. So in this case, we will just be covering a basic binary mixture, and the thermodynamic property under study is on molar volume. So let me read the word problem first. At 25 degrees Celsius and atmospheric pressure, the volume change of mixing of binary liquid mixtures of species 1 and 2 is given by the equation delta V, or the volume change of mixing, is equal to x1 x2 multiplied by the quantity 45x1 plus 25x2, wherein the volume change of mixing is in cm cube per mole. At these conditions, V1 is equal to 110 and V2 is equal to 90 cm cube per mole. Determine the partial molar volumes of V1 and the partial molar volume of 2, which is V2, in a mixture containing 40 mole percent of species 1 at the given conditions. Okay, so I will not write anymore the given, okay, and the required. I will just go directly to the solutions. So what are the mathematical relationships that you need to take note when you talk about uh, getting the partial molar volume of 1 and partial molar volume of 2 if you are given a mathematical equation between the molar volume change in mixing and or as a function of composition. So let's start off first with the idea that um, for this case, I think we are just used to getting the partial molar volume if we have the volume of mixture data as a function of composition. But this time we have the volume change of mixing, or the volume change on mixing data. So we can actually do this by establishing that the relationship between the volume change of mixing and excess volume is that both of them are equivalent. So whatever volume change on mixing values you were able to obtain, it's actually equal to the excess molar volume of that mixture. Okay? And how will I determine, or how will I know the partial molar volume, since that is what is required? From the volume, or the excess volume data rather, that you are going to determine, of course, there are mechanisms, or there are procedures to determine the partial molar volume excess property, which I will present later. I will write the equations later. And if you can recall in your topic, in the topic on excess properties, remember that the the partial molar excess property of a species in a mixture is equal to the partial molar volume, okay, of that component minus the partial molar volume of that component in an ideal solution. So again, for this one, you are just sticking to the operational definition of what an excess property is. So essentially, it's the difference of the actual partial molar thermodynamic property minus the partial molar thermodynamic property under ideal solution condition. Okay, but essentially, if you think about it, the partial molar property is for the actual solution. But how will I know the partial molar property of a particular species under ideal conditions? So, you need to also know or remember that whatever the pure component property of the species is essentially equal to its partial molar property under ideal conditions. So, what you will actually make use for this one later is your value of Vi, which we are actually given in the problem. So this is your V1 and this is your V2. So essentially, so your V1 and V2 are your partial molar V1 and partial molar V2 under ideal solution conditions. Okay, so please take note of those mathematical relationships. For the meantime, I think it would be best to start with a step wherein we are going to establish the mathematical relationships. So this is purely computational. Hmm. So establish mathematical relationships. So apologies for my occasional coughing. So the partial excess properties for binary mixtures, properties for binary mixtures. Hmm. Okay. So I will write here all of the equations that I have prepared before I start doing the solution. We have here, of course, we know for a fact that the molar volume changes on mixing is equal to excess molar volume. And for the partial excess property, or for the uh, partial uh, excess molar volume for component 1, the equation here is VE minus 1 over x1 times the derivative of dVE over the x1. And then for the partial excess property, the partial excess volume for a component 2, that will be the excess volume of the mixture minus x1 times dVE over dx1. So those are the partial excess properties or the partial excess volume for component 1 and component 2 respectively. Okay. Now, at this point, if you can see here, we have already the equation for the delta V, which is equal to VE. So the next step that we can do is to actually solve for the derivative or the dVE over the x1. So for step 2, let's solve for the dVE over dx1. So for this one, we have oops, dx1. Ah, I think I need to write it first, the original equation. That is, so I have this here in my scratch. We have 45x1 plus 25x2. So we need to get the derivative of this one. So I just did some minor manipulations in the equation. So I distributed the x1 and x2 on the outside, distributed here in the two terms inside the parentheses. We have x1 squared x2 plus 25 x1, or let's just use what I did here, x2 squared times x1. And then I expanded, okay, I made sure that everything is with respect to x1 so that I will not have a hard time getting the derivative later. So I expounded it 1 minus x1 squared times x1. So at this point, I will get the derivative of excess molar volume with respect to x1. So for this case, what I will do is I will, for the calculus part here, I will, this is a product rule. So this will be my u and v, and this will be my u and v. So it will be, if you can recall your product rule in calculus, it will be u dv plus v du. So I will make this one fast since this is just basic calculus. So again, apologies for my occasional coughing. So this will be 0 minus 1. So this will be u dv plus v, and then derivative of 45, that will be 45 times 2x1 plus, okay, I'll just write it one here below, 25 times 1 minus x1 squared, so that will be u, and then my dv is just 1 there, and then plus x1 times 25 times 2 times 0 minus 1. Okay, so after I processed everything, the value that I was able to obtain is, or the equation or the derivative is equal to negative 135 x1 squared. So if you want to further add more details before this line here, you may do so, but to save time in this video, I will just write my final answer. 1 minus x1 squared. So I already have my equation for the dVE over dx1. So I think what we can do is to solve for the necessary equations before we come up, necessary values before we come up with partial molar V1 and partial molar V2. Now, we will not make general expressions. Take note that we are not required to look for the general expressions of the partial molar V1, partial molar V2. So I think it would be practical for me to just obtain the values right away given the value of x1 to be 0.40, because according to the problem, uh, what is the partial molar volume of V1, or the partial molar volume of 1 and partial molar volume of species 2 in a mixture containing 40 mole percent of species 1 at the given conditions. So I think it would be good or it would be practical for me to proceed with step 3, which is to solve for dVE over dx1 and VE itself at x1 is equal to 0.40. I think this will be a more practical way to do it, to make the entire problem a little bit shorter to do. But if you are my if you are a student of mine, or if you are required by your teacher to elaborate everything, please do show all of your solutions. Okay? So in this case, I will not anymore, you know, write the whole substitution. I will just substitute it directly in my calculator. But if you are required by your teacher to elaborate your solutions, please do show it to him or to her. Plus 40 times 0.40 plus 25 times 1 minus 0.40 squared. So my answer here in this case is 3.4. So if you are required, that will be cm cubed per mole. And then per mole fraction. I think this is per mole fraction. But it actually doesn't matter because the mole fraction is, not really that relevant. But if you study absorption processes, you will find out that they make use of the unit mole fraction as a unit. Okay, for VE, the equation for VE that we have is this one uh, here. So I think we can just use this one right away to get the value of our VE. I will use my calculator right away to substitute. 0.4t squared times 1 minus 0.4t plus 25 times 1 minus 0.4t squared times 0.4. That will be 7.92. So from this one, you can actually realize that, oh, it's a positive value. So there is actually expansion that takes place after mixing or after forming a mixture containing 40 mole percent of component 1 because the value of the excess volume is positive. So your instructor might ask you, okay, after you mix the two substances forming 40% of component A, did the mixture expand? So the answer for this case will be yes, because the value of the excess volume is positive. Okay. So in that case, so you already have the values for the VE and the dVE. At this point, I can now solve for the excess molar volume of component number 1, and I can solve for the excess molar volume of component number 2. The partial excess molar volume, rather, of components 1 and 2. In component 1, okay, so we have here V1E. So the equation as presented earlier is this one. This will be VE times, VE minus 1 minus x1 times dVE minus dxi. So we will do that. VE, that will be 7.92 minus, oh, I think I have a mistake here. This is plus. Okay, apologies for the mistake. This is plus, and okay, apologies for my occasional cough. 1 minus 0.40 times dVE over dxi. 3.4. So the mole fraction value there, actually you could just remove this one. It's just a nuisance, but maybe for your other courses like separation processes, when you study absorption, you will actually notice that there is part of the units for the mass transfer coefficient will be mole fraction. So yeah, just for you to get used to other textbooks. All right, so my answer for this one, 1 minus 0.40 times 3.4. So I have 9.96 cm cube per mole. And but this is not yet the final answer, okay? For V2, that will be 7.92 minus 0.40 times 3.4 minus, so 6.50. So they have a positive value. So it contributed in the expansion. So both of them. Okay. Alright, so those are the V1E and V2E for this word problem. Now, this is not yet the final answer because if you can recall, we are required for the partial molar volume of component 1 and component number 2 at a mole fraction of 0.40. So let's recall the definition. So we have V, let's just use the generic, the excess, the partial molar excess volume is equal to the actual partial molar property minus the partial molar property at ideal in the ideal solution condition. So remember that the partial molar volume of a species in a mixture at ideal conditions is just equal to the pure component property or the pure component volume. In this case, for you to know the partial molar property, you just are going to transpose that one and you will get partial molar property is equal to the excess property plus the pure component thermodynamic property. So basically that's just how you are going to do that. For partial molar V1, so that will be V1 is equal to partial excess of V1 plus V1 pure. And that will be my V1E is 9.96 plus V1. What is my V1? It's actually given in the word problem. 110 and 90. Okay. I hope I can remember the 90. 110. So my answer will be, that will be 119.96 cm cube per mole. All right. And then for my V2, same case, you are going to have V2 is equal to excess property V1 V2 plus, so this one, my V2 value is V2E value is 6.6 plus 19. We have V2E, or did I write? So that will be 96.56 cm cube per mole. Alright, so I'm done. So that's it. So what do I get from this word problem? You now found out that excess properties, partial molar properties, and property changes of mixing properties can be obtained. They are just related from each other. Okay? So that will be all for today. Thank you so much for watching my video. And I hope to see you soon in my other lecture videos related to chemistry and chemical engineering. Bye guys!